There's metabolic restoration. Slow wave sleep is also involved
James,
in.
we finished the slow wave sleep.
Ah.
Now it's REM.
Yeah, okay. REM sleep. Wait, where am I? Ah, we're now at the Prisma Fit MRI scanner, which is the third scanner we have in the lab here. They're all quite similar. They're all 3 Teslas here, but we're currently in the process of building a 14 Tesla MRI scanner. And when that comes online, it will actually be the most powerful scanner in the world for scanning humans. I should probably do a video about that. Anyway, back to sleep. Let's see what happens inside our participant's brain when they enter REM sleep. Our participant has gone through light sleep and slow wave sleep, and then things change dramatically as they enter our final stage, REM sleep.
This stage was first discovered in the 1950s by Dr. Eugene Azorinsky. And it looks so much like awake brain activity that when he first noticed it, he assumed that his participant must have woken up. He went in to check on them, only to find that they were fast asleep, and their eyes were making these strange, rapid movements underneath the eyelids.
I say!
And that was in the 1950s, so before that, the whole of human history, we didn't know that REM sleep even existed. Using fMRI, we can see that the visual areas of the brain are highly active during REM sleep. And this is because this is when most of your dreams occur. While you're awake, these areas are responsible for taking in visual information from your eyes and then generating your perception of the world. But when you're asleep, there is no visual input from the world. So it seems that in REM sleep, these regions are instead generating the visual perceptions that you experience when dreaming. To do this, they are essentially drawing on your memories to create the new and bizarre experiences that make up your dreams. But why are dreams so bizarre?
Chicken and the egg now!
And why do we even have dreams? Well, the truth is, we don't really know. Yeah, sorry. But fMRI research is very much at the forefront of trying to find answers to these questions. There have even been studies where experimenters have tried to decode brain activity to work out what you were dreaming about. With fMRI, it's possible to create a sort of template of how the activity in your visual cortex appears when you're looking at different things. For example, your brain activity might look a certain way when you look at houses, another way when you look at aeroplanes, and then a completely different way when you look at dolphins. In one study, the researchers recorded these templates. The participants then went to sleep, and the researchers tried to guess what they were dreaming about based on the activity in their visual cortex. They just matched the templates with what they could see while the participant was dreaming. When they woke the participants and asked them what they had been dreaming about, they found that sometimes it matched up with what the researchers could see from the brain activity. This technique raises the possibility of us one day being able to read people's dreams using fMRI. I hope that now you can see that these MRI scanners are some of the most important tools in neuroscience, because they offer a window through which we can observe the living brain. Whether you're asleep or awake, fMRI lets us map the activity of the mind in remarkable detail, shedding light on the most complex structure that we know of in the universe. Using these images and the other tools of neuroscience, we are finally beginning to decode the biological blueprint of who we are. That brings us to the end of our short tour of the MRI lab. There is more information though scattered around the lab, so please feel free to carry on exploring the space, and I might see you there in another video.